Welcome everyone. I'm very excited to be back here again today at the DDN booth following an exciting announcement yesterday of our strategic partnership to unlock the power of generative AI in enterprises around the globe with the power of DDN and the power of Vultr. I'm here today to continue the conversation to specifically talk about how enterprises in 2024 can move beyond the art of the possible to begin to realize outcomes and scale for growth with a proper enterprise architecture for generative AI. And it's important to remember lessons from the past, because with the debut of the H100 and now the new H200 and GH200, what we understand from the past is how to properly build a global architecture to fuel the next generation of enterprise applications. We have done here before. From client server days to the initial debut of web applications, enterprises learned how to stand up, build, test, and deployment environments to be able to scale web applications all across the globe to where people live and work so they can access our goods and services and information about our companies at their fingertips on their desktop, leveraging a simple browser. When you roll the clock forward in 2010, we started to see a faster, easier way for developers to be able to build and deploy new cloud-native applications to again quickly stand up, build, test, and production and deployment environments to push compute power as far to the edge as possible to make access to our goods and services more globally accessible for consumers that were now accessing us via a mobile phone in new locations that we never dreamed of possible before. And now we're entering a new digital frontier with the debut of the latest generation of NVIDIA GPUs. We have now hockey sticked Moore's Law and the possibility for delivering truly personalized digital experiences, one-to-one experiences powered by generative AI is now an actual reality. And with the dawn of this reality, we are now in a new generation, a new epoch of cloud architecture, where we are now putting GPU at the core as we rebuild all of our cloud-native applications to leverage all of our enterprise data so we can start delivering personalized content, personalized experience, personalized media for every single consumer, every single worker, wherever they live and work around the planet. And it's important for us to understand what are the barriers for us to unlock the potential of this revolution. And the important point here is that we need to accelerate and move fast. Now, in the typical life cycle that we've all been experiencing in 2023, as we seek to uncover the art of the possible, we've noticed multiple bottlenecks. How do we access the GPU? What's the latest generation of GPU? How do we rethink storage? How do we rethink networking? How do we rethink the physical layout of our data center? How do we secure more power? When you look at all of the steps of what's required to rethink everything from the data center floor to the incoming sustainable power to how we actually drive the networking, how do we drive the storage, how do we actually provision and enable the GPUs, we have multiple steps in a very long process that actually impedes us from doing anything other than tinkering and experimenting and dreaming of a possible future that we might not be able to achieve faster than our competitors. So what we believe is, because of the urgency to move fast, we need to go to a new model. The new model is not retrofitting your existing data center and figuring out the complexity of the networking and the storage and figuring out how to actually keep pace with the ever-changing generations of GPU that are coming out from NVIDIA. The trick is to move to a wholly cloud model. and enable a cloud service provider to take responsibility for building the data center capacity, securing the sustainable power, putting in place the world-class AI-enabled storage from DDN, and also keeping current with the latest generation of NVIDIA GPUs so that you can have instant on to begin to move beyond experimentation and begin to move to production deployment. But just moving to a cloud GPU model is not enough. Everyone talks about, I'm just going to rent a GPU in the cloud, my problems are solved. That is far, far from reality. The reality is renting a GPU is not enough. The complexity of configuring everything around the GPU, the drivers, the underlying software to enable AI development, TensorFlow, PyTorch, cuDNN, your CUDA drivers, all optimizing the networking and optimizing the storage with our strategic partner DDN. That level of complexity impedes the ability for ML engineers to do what they do best, which is to build and train models. What ML engineer is a systems administrator? None. What ML engineer is a storage engineer? None. What ML engineer is a networking engineer? None. These are the challenges that you need to leave to your cloud service provider so that they can work with partners like the folks here at DDN to give you the best possible environment to eliminate all remaining bottlenecks so that in 19 seconds or less, you can get started spinning up an H100 training cluster with all of your data from DDN storage to begin training and fine-tuning your model, and then within seconds spin up worldwide clusters to actually run production inference. It should be that easy. In the jobs to be done profile for your ML engineer persona, and nowhere in that jobs to be done profile does it says that they actually are a systems administrator. Their job is to build, test, and deploy production models, and that's what we're going to enable. And we need to move beyond what we have done in 2023, standing up large training clusters. Standing up large training clusters does nothing to deliver outcomes to our consumers and to our employees. We need to put in place a proper application architecture where we can train in regional centers and fine-tune on local data sets and then push as far out to the edge as possible all of our train-tuned models for production inference. We spent the past 2 decades pushing compute power to the edge so that consumers, wherever they lived and worked, had optimal performance on their mobile and desktop devices to get an actual experience. And now we're going to move to a model where every one of those experiences are powered by AI, but it has to round trip to a server machine in Santa Clara? That makes no sense. A new global architecture is needed to go beyond training and to actually push computational resources, push the GPU, push the storage as far to the edge as possible. And as we think about this new model, we also have to take another lesson learned from the past. In the core world of cloud compute, we allowed the promise of the cloud to actually be eliminated because instead of hyperscaling our growth, we hyperscaled cost and complexity and led to the trillion-dollar paradox where the core cost of your cloud infrastructure suddenly became so exorbitant it was nearly impossible to scale profitably, leading many to wonder about repatriating workloads back to on-premises data centers. Now, this trillion-dollar paradox in core cloud compute, it's important to not let it become the $10 trillion paradox of generative AI. And to eliminate this paradox, what we need to do is unlock the potential of composable infrastructure, leveraging innovation in open source LLMs that are lighter weight, faster, more performant, use less energy, less prone to hallucination, and actually give you control over not only the data, but give you control over all of the explainability and all of the accuracy so that we can actually do more with less and have control over our destinies. So with the power of cloud server provider like Vultr, unlocking the potential of open source, putting in place that proper global architecture, moving fast and leveraging the best-in-class components for enabling storage of all those large data sets you need to train your open source model through DDN. That's the reality we need to achieve together to accelerate AI ML workloads worldwide in 2024. So with this, we believe, again, a new architecture is needed for global cloud compute for enterprises in 2024. That new global architecture is what we are here pioneering today with DDN. Vultr and DDN, the only strategic partners that are capable today of fulfilling at global scale across 32 regions around the globe, large-scale H100 training clusters coupled with large-scale GH200 clusters for inference to enable you to have optimized storage to deliver all of your training data, to deliver all of your inference with top-of-the-line NVIDIA GPUs everywhere in the world at the lowest cost and the simplest, fastest way to market. We couldn't be more excited to be here again today with our partners DDN. If you're looking to actually move from large-scale training sets and the art of the possible to delivering real enterprise outcomes in 2024, come talk to us and let us help you architect for the future. Let us help you architect for growth. Let us help you architect for the generative AI revolution. Thank you so much.